That was Alan David. Good record. And from the group that should have written Star Wars and didn't. The Spirit of the Age. My best friends, Hawkwind!
That's on there, isn't it? Yep, that's on there. Let's hope. Oh, I probably should have put it on there. That was, yes. Let's see if I can get back to me. That was Quark, Strangeness and Charm by Hawkwind. I'm Pam Hoffman, Everyday Spacer. At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in Germany. We're broadcasting live from Thousand Oaks, California. Tonight I'm here alone because Jeff is traveling. And I see some comments. Let's start there because there's some pre-show banter. And Jeff says hi. And then I was saying hi back. Let's see, where are we? Scott said, hi, Jeff. Now, Jeff says, oh, I'll go with this one. I'm going to miss you here with me because we have two screens going. And a lot of times it's very, very helpful to have two of us. And I said to Scott, because Scott came on. Did I do that one? Hi, Jeff. Yeah, hi, Jeff. And then Scott, I said, we'll miss you. Scott goes, well, I'll miss him on that side of the screen, but you got this. Thank you very much. I appreciate that. Now, here's the thing. Jeff, I'm in Michigan at the moment. I'm not able to add as much chaos this week. You might add more. I got to tell you. True that. Well, yeah, I played the Quark's, the first minute of the Quark, Strangeness and Charmed. I'm not sure you heard it, and I realized I probably should have downloaded it into this program. Oh, yes, Hawkwind is very interesting. Sounded like you did, in fact, hear it. Hi, Janie Becker. Thank you so much for joining us. All right. Yes, I'm really excited about this lecture, too, because I love this topic. All right. Let me go into it. This is a Crunchy Topics show, and I'm going to talk about particle physics, some basics, and some recent news. We'll be back in 8.3 seconds. We mentioned Crunchy Topics, and we're talking about something that's a bit more science-y than our normal. Oh, okay, let's see. Did Hawkwind cause the Texas Super Collider to be canceled? I could not tell you about that, Daniel. Welcome. Thanks for joining us. Oh, you know what? I see something here that I screwed up. This is not Janie. This is someone new. Shreyan Kumar. Thanks for joining us. I really appreciate that. I see that they're both green, and that's what threw me off. All right. So, again, Crunchy Topics, a little more sciencey. And earlier this year, we got a request for more crunchy topics. So that's what we're going to deliver. We tend to get more RSVPs on the meetups for Crunchy Topics as well. And my feeling is that few things are more satisfying than delving into something you enjoy learning more about. And for me, one thing that includes is reading about particle physics. I remember my first book, and we tried desperately to find that title and the author's name, and it just did not turn up. I have the book somewhere. Perhaps one day I will find it. All right, so I would like to start with something that you probably already know about. Let me go cue that up. And then I will share. Here we go. Yes, there it is. And what I'm talking about is the atom. And I think most of us have some understanding of the atom. This is one of the basic components of all matter. Everything is made up of atoms. We probably learned about this in school. And some of the real simple parts of it are the nucleus of protons and neutrons and the cloud of electrons that kind of swirl around them. The thing that might not be as clear to everyone is that these have been, well, broken down into further parts. And that's where we're going to get into the particle physics part of this conversation. So, simple stuff: protons, neutrons, electrons. And one of the ways we found out about these were these, a deeper division of this is by throwing them into an accelerator and then smashing them together, and things just went flying off of it. And that's where we came up with these other particles. Let's see if they talk about it here. Yeah, I thought they did. All right, but I have some nice, let me do this too. I have some other nice tabs open for this, and we'll get into what exactly they are. And the wonderful part about this too is we get into these different forces, like electromagnetic force, nuclear force, and gravity. Anyway, we'll see those more in just a minute. I thought they broke it down into what kinds of things they were, but I'll go into here because we heard about it already. Quark, Strangeness, and Charm was the song, and they actually are talking about these particle physics items. All right, so, and we're going to talk about the particle, which is, in this case, a minute quantity or fragment. That's 1A, 1B, a relatively small or smallest discrete portion of something. And then they have a couple of other things. We're not going to talk about this Eucharistic wafer, for example, and we're not going to talk about the expression of a speech. All right, so we're going to talk about mainly the first three things of this: basic units of matter and energy: molecules, atoms, protons, electrons, photons. Only we're going to dive deeper in because those are kind of the first level of basic things. And particle physics is the study of these elementary building blocks of matter and radiation and their interaction. And that radiation part is what I was talking about with the different forces. Oh, and I see Cliff is here. I'll flash it up in a minute, Cliff. So yeah, and their interaction. The fundamental particles are summarized by the Standard Model. I've got a picture of that too. This includes leptons, such as the electron, the quarks that make up protons and neutrons, and gauge bosons. That's new to me. When I read my first book about it, they weren't really talking about bosons of any sort. These mediate the forces between the other particles. And this particular place has, this Nature portfolio site has other articles about it. All right, I'm going to go ahead and show you this nice Standard Model because I like this one very well, because to me, when you organize information like this, what you're thinking about is how they relate to one another. All right, and there's four basic types. We've got quarks, leptons, bosons, and Higgs boson. Like I said, the bosons, I don't remember those being in the first book I read about it. All right, so this is a really great article. And one of the things I really like about it too is this is the Department of Energy, is energy.gov site. And I'll show you another part of this too, but it has this great image and then some good information about the Standard Model of particle physics. This is a scientist's current best theory to describe most of these building blocks of the universe: quarks, bosons, so forth. The one, and then they have the forces in there too, the four fundamental forces that govern the universe: electromagnetism, the strong force, the weak force, and gravity's in there, but we don't know much about that yet. Electromagnetism is the photons involved, electric fields, magnetic fields. The strong force, which is carried by gluons, binds together the atomic nuclei. Let's take a look at the picture though, because I want to see where the gluons fit into this. Yeah, we've got, let's see. I think they're in here as, yeah. All right. We got a lot to learn still. And then there's all kinds of, there's the charm. Top, up, down, straight, bottom. Somebody had fun with that chart. So yeah, like they said, despite its success at explaining the universe, the Standard Model does have limits. The Higgs boson gives mass to quarks, charged leptons like electrons, and the W and Z bosons. We do not yet know whether the Higgs boson also gives mass to neutrinos. So yeah, there's a whole big argument, and I did a talk about this a long time ago about, well, they call it dark matter. I don't really care for that term because to me it's more like an anomaly. It's a mass anomaly, and I did my whole talk. It was called "What's the Matter?" because we don't really know. We still don't know. But then there's things like dark energy that have come up. Lots and lots and lots of mysteries still to solve. So yeah, if you like this kind of thing, absolutely throw your head into the ring and take a look at it. So this Department of Energy, Office of Science, really has some contributions to the Standard Model of particle physics. And they've supported research in this area. Let's see. All right, the Standard Model of particle physics facts in all ordinary matter, including every atom on the periodic table of elements, consists of only 3 types of matter particles: up and down quarks, which make up the protons and neutrons in the nucleus, and electrons that surround the nucleus. The complete Standard Model took a long time to build. And in fact, when I read this, my first book, I don't even remember a, quote, standard model. So to me, this is kind of new. But they say here that J.J. Thomas discovered the electron in 1897, and scientists at the Large Hadron Collider found the final piece of the puzzle, the Higgs boson, in 2012. And you may have recalled that there was a lot of news about that at the time. All right. There are some other resources, and I guess this is contributed by these folks here: Hitoshi Maruyama and Kurt Risselman. All right, so what I really like about this was this other page here too. This is kind of the main page, the homepage of thisenergy.gov. So, you know, they do tell the mission. It has the mission to deliver scientific discoveries and major scientific tools to transform our understanding of nature and advance the energy, economic, and national security of the United States. I think it's wonderful to understand what this department is all about. And when I looked down a little further, I was really excited to see that they had an article. Okay, it was here. That's so interesting when you redo everything. All right, I think I do have it. I think it was this one here. What does the Standard Model predict for the magnetic moment of the muon? So what I really want you to understand about this is that these particles, the muons and the bosons, the quarks and all that, are even smaller components of what we were thinking was, you know, what everything's made of, the smallest you can go. But in fact, we've actually gone deeper. And I was saying to Jeff that, you know, we haven't really seen anything smaller. And then he mentioned to me that, well, we've taken an awful lot of energy to find these things. And really they're inferred, because when you smash particles together, you get this, you know, the trail. You don't even see the pieces, you see the trail in what they call it's a bubble chamber. So what happens is they've got this material, I'm not sure what it is, maybe Jeff can put it in the comments for us. And when these smash together and things fly off apart from it, they go into different directions and they make swirls, but they're all the trails from these things. We haven't even actually seen the particles themselves. And one of these colliders is right here. There's a picture of it right here. High energy physics community is eagerly anticipating the announcement of the world's best measurement from the Fermilab Muon G2 experiment later this year. And that has to do with this particular article right here. So yeah, atoms are not in fact the smallest parts of what makes up all matter in the universe. There are these other, and I just love this chart, this whole big thing about the photons, gluons, boson, the Z boson, W boson, the Higgs boson. Let's see, these orange ones are the quarks and the green ones are the leptons. Quarks are up, charm, top, down, strange. Remember, quarks, strange is charm. And I think things like songs, in this case, the one by Hoffman, can really help us remember things. Think back to all the jingles that we heard when we were watching commercials, and you remember them long after you have seen the commercial. And this, in fact, helps us with this particular song as well. Quark, strangest charm. On the bottom here, we have tau, muon, electron, tau neutrino, muon neutrino, and electron neutrino. And those are kind of fascinating because neutrinos don't really interact with anything. They pass right through. In fact, they're passing through you right now in the millions, and we don't even know it. All right, so let's see, where was I? Let's see, the Britannica definitely has, I thought it had a subatomic particle. When you renew stuff, things change. There it is, subatomic particle. So they do talk about how these are elementary particles of the various self-contained units of matter or energy that are the fundamental constituents of all matter. They include electrons, neutrons, protons, neutrons. And that's what we knew. And now we know that there are even smaller things. Quarks, muons, neutrinos, positron. Antimatter, it's funny because in the case of antimatter, we don't really have as much as we think we should. Oh, you know what? I'm going to go back to the comments because I see Jeff left a message. Let's go back there and take a look. All right, and I'll flash this now. Hi, Cliff. Thanks for being here. Really appreciate that. All right. Different directors use different mediums. We covered some of the types in one of the Zooniverse citizen science projects. Oh, detectors. Sorry. That's the word I missed. I read it wrong. They use different detectors with different mediums. Okay. Yeah. Okay. I'm trying to remember the Zooniverse projects that we talked about. If you remember, Jeff, that'd be great. Go ahead and put that up there. Oh, I see. I love these when they pop up. All right, so, there's lots and lots of wonderful sources like Wikipedia and Britannica, and absolutely, if you want to deep dive in all these different things, these are links to more and more more information. And boy, we haven't talked about photons. Oh, Jeff says I don't remember. Alrighty. Well, we definitely have the shows that are cached on the Everyday Spacer YouTube channel. So that would be a really good place. And we created a playlist. In fact, there's a playlist for a couple of different things. All of the people we've had on our show as guests. And then we've got the kind of the top 10 that people really liked on our show. There's a few of them. You can see the playlist when you go to the channel. All right, I'm going to go ahead and take a look at, okay, this was something else, I think, too. Oh, darn it. What do we got here? Yeah, this might be it. Nope. Not what I thought. I wonder if it's in here somewhere. All right, well, maybe I can find that later. But I did like the Wikipedia. They have some great pages on all kinds of different topics, and they really make it understandable. Oh, I'm going to go see what Cliff has to say. All right. Lots of talk about dark energy. Does it exist? And now the Big Bang is 27.7, I think you mean billion years ago as well. Yeah, Jeff was telling me about that the other day, that it seems like the age of the universe is about twice as much as we originally thought. Isn't that what you were saying, Jeff? And I think you said something like 28, which we kind of thought it was 14, but thanks, Cliff. All right, so back to the Wikipedia page. Jeff answered. Let's see. Thanks, Jeff. The Big Bang being that far back means that they don't need as many fiddly bits to explain hyperexpansion. Okay, excellent. Yeah, and I thought I saw something with the Webb Space Telescope, that, yeah, this Big Bang theory might not be exactly what they thought. Yeah, 27.7 billion years old. I thought you meant billion. Thanks, Cliff. All right, so the wonderful thing about the Wikipedia pages is they do give you a lot of, first of all, a lot of good information, and it's kind of in understandable forms. And then, of course, as you see, there are lots and lots of these links to other pages in Wikipedia with more descriptions. And here's that other standard model of particle physics, and I don't like it as much because, like I said, when you look at this DOE one, you get the sense of how they interrelate to each other. And I really like charts like that. And I'll give you an idea about that, because when I was studying electronics for my degree, I have 2 degrees in electronics. I was trained to design computers. And we studied things for that in some ways that didn't make quite as much sense as a chart like this. Once you saw a chart like this for things like power and resistance, and anyway, all the different things, it made more sense when you could see how they interacted with each other. So that's one of the things I don't like about this. I don't think you get as good a sense of what they mean to each other. All right, and I just saw another comment from so this new concept of how old the universe is from JWST as well, Cliff. Cool. Thank you for that. I can totally believe it. We're going to learn so many things, and we're going to have more and more questions, because that's how it works. Whenever we discover something, learn something, deep dive into something, it just helps us create more and more questions for ourselves. And it's kind of beautiful. Jeff, that's an old photo. Yeah, he still kind of looks like that, though, doesn't he? All right, so great sources of information with the Wikipedia pages. Yeah, okay. And like they go into this, quarks cannot exist on their own, but form hadrons. I mean, you can really, this is a hell of a rabbit hole, and it just keeps going and going and going. But that's kind of the fun part about it. Yeah, they talk about the history of it, the standard model. Oh, okay, so this is kind of cool because they talked about it gaining widespread acceptance in the mid-70s. And, well, that's probably about when I read that book by Nita. Yeah, I really wish I could find that. Because, it's been so long, it's completely possible that I did read about the standard model, but that I don't remember. Oh, I see. I've been on YouTube a long time. No. All right, let's go ahead. See, this is also about the standard model, but I think they have a different starting point, particle physics and the standard model and stuff. They go into the standard model itself. So I did find some things about kind of the current state, but I'm not pleased with I want to find out more. I want to do more digging. I'm going to flash real quick through some of these things, because there are some really cool possibilities. Like, you could take this free course on particle physics. I mean, look at that. Isn't that wonderful? And I think this particle physics reveals the profound connections underlying everything we see, including the smallest and largest structures in the universe. Find out more here about particle physics, how it propels U.S. progress, and our community's strategic plan. That's U.S. particle physics. And I think there might be some training in here, a free training in here too. Or maybe it's the next tab over. Let me go. Go see what you guys are doing. Okay. James Webb's found an old galaxy that has no hint of dark matter in its structure. That is very interesting and very confusing, because it seems unlikely. I'd love to talk to you more about that when you get home, Jeff. All right. Let's see what else is in here. Like I said, I'm not happy with how I've done this and what I found, so I think that's going to be a part 2. But hang on to your hat, though, because Jeff, let me pull that one. Jeff is talking about something else next week. Oh, hi, Sharon Kamar. What are the prerequisites if someone has just begun college. Oh, so I'm guessing, and I'm going to go back to this one because it seems likely that if you just want to learn this, Shreyan, I think you can just go and learn it because it's a free course. And they do say level 1 introductory here, 5 hours of study. So, and a lot of people have given it for, good ratings, that kind of thing. Oh, Daniel, I see. Dark matter matters. Create an account, sign in. I think that's all it requires. Whether you've been to college or not, it's just what would you like to learn about? And I read an interesting article today because someone was talking about his friend dropped out of a science course because she constantly felt stupid. And I got to tell you, I don't call this feeling that exactly, but when I study stuff like this, I feel out of my depth. Let's put it that way. All right. So I feel like I'm out of my depth, but you know what? It's always fun to go and learn it. And after a while, you're like, oh, maybe I can slot this information into here. Or I see how these things fit together now. Like, I'll give an example. When I was learning electronics, we understand how electronics flows. We don't know quite how. You can talk about some similar things, though, like we know how water flows through pipes, and we did that a lot. We talked about how water flows through pipes. So building that bridge between the water flowing through the pipes and understanding that to, having a feel for how electrons move too. And then it's either, maybe they call it electrons or holes. We don't really know. But you can still learn from it. So if you want to take this course, absolutely, I think you should. And we got some comments from Jeff. So let's see. Dark matter matters. And then, physics and math. And you know what? I don't even know if I would go so far as to say you have to have a prerequisite in that. It might help you understand things more. And if feeling out of your depth, that out of your depth feeling is uncomfortable, I totally understand it. But sometimes it's good to stretch yourself because the next time you do so with something similar, you have some places to slot that information in. So by all means, I would say go for it. And you're very welcome. And I think you said that to Jeff as well. All right. So let's see. Again, I just found a bunch of different cool sites about articles. Here's another one, Coursera, Particle Physics and Introduction. But I really, really wanted to dive into this more. LibreText's Introduction to Particle Physics. And maybe some places in here they have what might help you learn more. But I don't even think I would worry about it too much. If you want to, especially this other one here, if you want to look into that, go for it. All right, so what else is here? And here's the other part of it. Let's say you do dive into this and go, oh, what the heck does that mean? Well, guess what? It's something else that you can look into. All right, what else is here? Oh, I thought this was kind of cool. It's from thought.com. Particle physics fundamentals. And I think this is starting to get into that, what's next with particle physics. I didn't get a chance to really deep dive into these articles. And see, it's from 2019. I want something that's a little more updated, and I want to really kind of sink my teeth into it a little bit more so that I understand how to explain it better. I just haven't had a chance to do that as much. Let's see. Is this I was trying to find the thought.com one. They had a printout when I was hoping we could get rid of all those ads and stuff. Okay, and this is from Wired Magazine. A novel type of neural network comes to the aid of big physics. Again, this is an article I think that's going to give us some kind of what's happening now, but I haven't had a chance to do too much with it. I'm going to do another episode on this topic for you. All right, and I think that's going to be, I got a lot of other stuff here, but I don't know that it's, breakthrough. Talk about a breakthrough, pave the way for the Higgs boson. What the heck's this one? Oh, this is a PDF of, and I think I saw somewhere else of, they used some of the material in this. All right, what's this one? So getting a preview of things like the exotic pentaquark particle, but I want to know more. And you know what? I get to play some more too. So why the heck not? I don't know why that's there. Isn't that funny? These reset themselves when you set them up. All right, what else is here? Oh, yep, here's another one. Is this the end of the particle era of physics upon us? And I think, yeah, see, I want to read these. Jeez. Pop-ups everywhere. And there's some other things here about strange quark, bottom quark, and I'm sure there's more. I wanted to find all those too, but I just haven't had a chance to. All right, let me come back to you here and go into the next part here. So yeah, I'll do part 2 so I can delve into this more. And I didn't get a chance to do as much digging as I would like. Also, like I said, it's a great excuse to play with particle physics. Jeff is taking on next week though, so stay tuned for my part 2 a little bit later on. But the whole idea here is that if you're into something, by all means delve into it. And we like to talk about things that you can do, and certainly studying a topic like this is something you can do. And I would say delve into it as much or as little as you like. It's part of you, and doing what you're into, it will feed your soul. All right, so Jeff had a comment. Let's see. That is for studying particle physics. I hit particle physics on the 2nd or 3rd physics course. I don't really know. It's been a while since I went to collage. Well, thanks, Jeff. All right. See, I knew you'd cause some chaos, even though you're all the way across the country. All right, I'm going to tell you about some stellar events this week. We're talking about July 28th through August the 4th. We've got a Delta Aquariid meteor shower coming up. The peak is the 29th and 30th of July. The Delta Aquariids is the name of this particular meteor shower. The date range is the 7th, July 12th through August 23rd. The peak is July 29th, 30th, and the best time to observe is after midnight. This radiates from Aquarius. The peak rate is 10 to 20, not great. The source of this is 96p Mach-Holtz. Now, unfortunately, we are going to have a very big moon to contend with. Let me show you that. All right, where are you? So here we go with the moon phase calendar from the Old Farmer's Almanac. And as you see, we've got July up. July 29th, we got a big moon. Way big, and it's going to be in the sky a lot. So unfortunately, I think that particular meteor shower it's going to be a bit of a challenge to see this year. Let's come back to me. So July 30th, the moon runs low. Still trying to figure out what that means. July 31st, Pluto and the moon are in conjunction, and it's Jeff's birthday. August 1st is the full sturgeon moon. And, I haven't really done this before, but I wanted to kind of talk to you about some cool resources. And I've mentioned the Farmer's Almanac before. And one of the things that's kind of at the top of this every month is a little segment about the month. Let me find the August one here. Yeah, so here are the 2 pages. And at the top over here, it gives you sort of a synopsis of the month. And I think I've mentioned this to you before too. So like in this case, Venus and Jupiter have both dropped into the solar glare, ending their lengthy reigns as evening stars. So that must be Saturn in the east, Jeff, that we see. Mercury remains just above the horizon in the western evening twilight at magnitude 0. Mars, 6 times fainter, hovers above it. The third, with Jupiter on the 8th, the Perseid meteor shower arrives, another meteor shower, that's in August though, arrives on the 11th and 12th of August, and it's best seen after midnight, when rural observers can expect a meteor a minute, and the moon is going to be good for that one. I see some more comments. I'll get to that in a second. Let's see. Oh, and they say, the moon won't interfere, making for an excellent viewing conditions. Where to go? Let's see. Yes, beginning around the 20th, Venus rises before dawn to become a morning star in the coming months. Saturn reaches opposition on the 27th at its biggest and brightest of the year. So there we go, Jeff. I think I think it's Saturn in the east that we're seeing when we get up really early in the morning. I also wanted to share with you something else, but I'm going to do that in a minute. Let's see what you have to say. Big moon for my birthday, and my sister Mary Jo Rue. Yay! How cool is that? James Webb also found a whole bunch of extremely old galaxies, and they're far too big to be only 500 million years old. From the Big Bang and Fitzwicky's and the Triple C theory work out 27.7 billion years, and it works. So here's when actual information experiments can help us understand better, and when it works, it fits. Very good point there. Yes, I love the Farmer's Almanac too, and there's lots of crazy weird things in there. So the other thing I wanted to make sure you knew about was this skymaps.com. I have that page up for you, and I want to demonstrate how you get some information there, because this is available to you every single month. All right, so we got skymaps.com. That's the website right there. We can see it here too. When you get to the skymaps.com, you want to scroll down just a little bit to find this download the latest issue, the evening sky map. When you download the latest issue right there, you can find the evening sky map for, and it might be, let's see, is August available yet? It might be July still. But very, very soon you're going to find August. Oh, yep, there it is. So for the Northern Hemisphere, you'll find the August download here with the big red button. July, June, they have a few months here. The Equatorial edition is going to be right here. Big red button is the current. Southern Hemisphere edition, again, this big red button is the current one for this current month. All right. So one of the things I really love about the skymaps.com is it makes a great journal. You can print out the 2 pages. I tend to put them back to back, and I'll write the date on them. I will draw little pictures of, like, let's say I see Jupiter and its moons. I'll put little pictures of where the moons were. If I meet people, I put their names there. Lots and lots of fun ways to use it. And let's get some more comments going here. Shreyan Kumar. So does the new Tyrol-based liquid state reveal any new mysteries for us? I am not aware of what you're talking about. And if you give me more information, we'll see what happens. Oh, a big time delay still. Oh, all right. I'll do my best to find your comments and show them. All right, Cliff, sorry about that. You're just so far away in Australia. Pretend like you're on the moon. It should work, right? All right, so let's see. Oh, I see. Go conformal cyclic cosmology. And I don't know about this. All right, so, and if that should be a topic of discussion at some point, we can do another crunchy topics of it. We'll have to do some research because, unless Jeff knows about it, I don't know about it. Scott, before the internet, the Farmer's Almanac was really useful. Yes, it still is. They sell 9 million a year, last I knew. Really useful. It was the only place to find lots of information that it held. Yeah, there's several almanacs. This one here is my favorite. This is the one I get every year. And I've actually upgraded to, because of course you used to have the one that you could hang. It had a hole in the corner and you could hang it in the barn. But this one's slightly bigger. The pages are brighter, so it's better contrast. And the text is a little bit bigger too. The font is a little, and my old eyes really appreciate that. Oh, we got a new, it's a new 5th state of matter found by the University of Massachusetts. Oh my God, that sounds so exciting. If you know more and you want to come on the show and tell us about it, that'd be wonderful. All right, so because it's August 1st, I was talking about, I wanted to make sure you knew about the Farmer's Almanac synopsis and the skymaps.com. Let me go ahead and finish this. I'll get to the next comment as well. August 2nd, the moon is at perigee. August 3rd, Saturn and the moon are in conjunction. August the 4th is our next Friday night show. Jeff wants to do another profile. Find out who he'll talk about shortly. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Also on August 4th, Neptune and the moon are in conjunction. Let me go ahead and get to the next. We got another comment here. I also like the old Physicist's Almanac. I don't know about that one. Jeff says, Shreyan, I don't know a lot, but they found that information may travel faster than light through it. Okay. Well, we know that light has traveled faster through. There's a substance. I mean, this was years ago. I read about that name because it came out before it went in. It was some weird experiment they did. But yeah, tell us more, folks. And if you want to show about it, we'll do some digging and find out. Who knows? I mean, I'll learn something, I'm sure. Yes, very cool. All right. Tell you what, if you have more questions, go ahead and post them. I'm going to wrap it up for tonight, though, because if you or somebody you know has done something interesting involving space exploration, science, and astronomy, we'd love to share our life. Join us again next Friday, like I said, August 4th, when Jeff will delve into a profile of Michael Collins. And you may recall that Michael Collins was the Apollo 11 astronaut who stayed in orbit around the moon while Neil Armstrong and Buzz Aldrin landed on the moon and spent a little time there. Does anyone know where Edwin Eugene Aldrin Jr. got the nickname Buzz? I'll tell you what, next week we'll answer and see if you got it right. Oh, thank you, Janie. You too. And stay hydrated out there. Oh, this is good. I love the way physics has changed. 100 years ago, it was all math. Now it's mostly data analysis and coding, and you can actually work with that data too. There are lots and lots of ways to color them. We've talked about that in previous shows. Maybe we'll talk about that again because I think some other things have come up with the James Webb Space Telescope. So Jeff, think about that. And Thomas, thanks for joining us. Thanks, Pam and Jeff. Good stuff. Keep looking up. Absolutely. You too. And with that, I'm going to go ahead and do a shout out to Thomas and Shreyan and Janie. Jeff, thanks for being here too. I really appreciate the backup in the chat. Daniel, Scott, Cliff. Yay. I said Janie? No, I didn't say Janie. Let's see. Who else? I think I got you all. I'm so grateful to you for being here. It's very quiet on this side, but thanks to you, I have been entertained well. I really appreciate that, especially the little preamble conversations we had. So, folks, keep bringing us your comments. Tell us what you want to hear. We are very interested in delivering on what you're most interested in learning about, like the topics we heard about tonight. Oh, thank you, Scott. It's Jeff. Well, he'll be back next week. I'm pretty sure, unless something weird happens. So thank you, folks. Have a great week. We'll talk about Mike Collins next week. All right. See you later. Bye.